be overwhelming. And I said stop, and I backed up. I started looking around online. I saw the smart FHIR guys that have their FHIR library, which is great. And I was like, okay, that's nice, but I want to be able to persist this data as well on the device. I don't want to translate from different formats. So I kind of used the FHIR stuff as a basis, especially for the FHIR parsing. I wrote a language pack and my own set of classes that could all be Realm-ready. That's kind of how we started out with FireKit. So what actually is FireKit is it's a DSTU2 implementation in Swift. And the difference between that and Swift FHIR is that it's all Realm-ready. So anything that's in FireKit is defined in FireKit. You can create an instance and immediately turn around and persist it on your phone. And then you can use Realm's API to search those resources, load them up, manipulate them, and keep them all on the device there. It also includes help with full serialization with JSON to and from, and that's using Swift 4's codable protocols. If you're not familiar with those, they're pretty cool. They do a lot of the heavy lifting for you. Everything in FireKit is also NS-copying compliant. So we can take an instance of patient and we can do a full deep copy on it and continue manipulating that copy. Look, structurally and value would be completely identical to the original. Also, there's a whole bunch of Realm extensions in FireKit, so helper methods. Like these are complex models, FHIR models, and working in a database with that can be kind of a pain in the butt. So there's some stuff there in FireKit that help with the update and deletion of those objects. And finally, it's all under Apache 2, so use it, redistribute it, manipulate it, sell it, whatever. Just some schmuck in Toronto. I'm just happy people are using it. So that being said, there are some limitations. For example, there is no API client in FireKit. This is mostly working with just stuff on the device itself. Although I have ideas, there's things that I want to do and places I want to go in terms of API client, but there's nothing there yet. This is all, like I said, pretty new in the last year, this stuff. Also, because everything is a Realm object, ultimately we are beholden to the rules of engagement for Realm. That doesn't mean terms of service, but it does mean things like if we're going to inflate a resource out of the local Realm database, Realm does not allow us to share that resource across thread boundaries, which isn't a bad thing as far as I'm concerned. Shared state across boundaries terrifies me. Also, anytime we are working with something out of the database, if we want to mutate that, so if we want to set a birth date on a patient, for example, we need to do that within a write transaction. Again, this is data, not necessarily a bad thing to maybe assert some integrity there. The last thing, there's a few others, but the most important one here, and this one kind of stinks, up until Realm 3, which was released about 3 or 4 weeks ago, there was no support for lists of primitives. So if you think of a human name which has like a list of family names and a list of given names, those are just arrays of strings. There's no native way in Realm to persist. So you have to wrap primitives if you're going to persist them, like a list of primitives. You have to wrap them. So instead of a string for family name, we have Realm string. For list events, we use Realm int, list of rules, Realm bool, so on and so forth. It's not confusing, it's just kind of lame. So, like I said, this is going to be mostly example driven. I'm just going to dive right into it. We're going to start off by creating our first resource. So how do we create a patient, for example, and then how do we persist that patient to our local Realm? So there's two things that we got to use. We need to use FireKit. That's where the actual FHIR schema is defined. That's where all of our Realm-ready classes are. And the Realm Swift that we import is the actual Realm API. That's what we're going to use to actually create the transactions, write to disk, read from disk, etc. So to create a patient, we simply create a new patient. Everything is in FireKit. That initializes it. It initializes the lists of things by default to be empty, so your human name will be ready to go. You can start appending human names to it. That's it. I don't know how much you say about a constructor. So next, if you want to give that patient a name, FireKit has a human name. We can provide a family and a given. Again, there's your Realm string because it's a list of strings. You can't use a string, you've got to use a Realm string because that's ultimately going to be persisted. And then we just assign that name to the patient. So here we have 4 realm objects, basically. We have a patient, we have a human name, and each of the realm strings. If we want to write that back to disk, that's all we have to do. We create a realm, which is basically, you can think of that as a connection to your local database. We start a write transaction, and then we use the Realm API to just add that patient. That's done. We don't have to do any translation. We don't have to convert to any other format. It's all there, and it's all ready to go. Now, because we are talking about databases, there is a notion of a primary key. So everything in FireKit has a primary key, and that primary key isn't the ID. It's not the FHIR ID of that resource. And the reason why is because I didn't want to conflict that with whatever might be on the server. I didn't want to make a decision as to who assigns the ID in your project. Instead, what we do have is there is a string property called PK. And it just defaults to a new UUID string, and that's set as the primary key in FireKit. That doesn't get serialized when you serialize it to JSON. It just stays within the realm and within the object. It never actually transfers over the wire. So those are just a little thing to know. We're going to talk a bit more about primary keys later and how they come, well, actually right away here, because we're going to retrieve some objects. So we got data into Realm, that's all there was to it for the most part. So how do we get the data out? So Realm provides us a couple of APIs. There's an objects API, which returns a list of results, which are lazy. And there is the object API, which returns one or none, and that's based on the primary key. So we can start to see where that primary key in the previous slide starts to fall in here. On top of that, FireKit provides a couple of Realm extensions. It's structured very, very similar to the objects and object API. We have resources, which you can use to provide, say I want to get all the patients with these IDs, so it's kind of pre-constructing a filter for you. And there's also the resource. If you don't know the primary key, for example, maybe you're grabbing a patient from a server and that patient has an ID, you want to check to see if it's in the local realm, you can use FireKit's resource with that ID. We're going to show you what that looks like. So, to get the objects, we can just tell Realm, give me all the objects, give me all the patient objects. And what's happening here is we're actually getting a results list back, and that results list is lazy. So we're not inflating any data yet. We're not incurring a penalty yet. We're just getting like basically pointer to those results, kind of like we're constructing the query. We can turn around and once we start iterating over those and accessing the properties, that's where we incur the hit. But of course, we don't want to be getting all the patients back all the time. We typically want to be filtering this somehow in a local database. So we can just use the filter function. That's part of the results class that comes back from Realm. And we just pass it in as predicate string, or we can pass it as predicate itself. So basically, give me all the objects where the gender is unknown or the gender is known. And we can continue to chain filtering because filter returns more results. We can kind of keep applying more and more filters if we want and narrow down that scope. And finally, there's also a sorted function, which we can use to define what fields we want those objects to be sorted on when they come out of the realm and when we actually start iterating over them. There's a whole bunch of information there. There's a big cheat sheet actually on the Realm website, which is a really useful thing. I find myself using that quite often, so there's more information there as well. Alternatively, we can grab something directly with the primary key. If we know the primary key, this is, it's not too foreign of a concept. We can just, very similar to what we have with the objects, but instead we say, get me this patient with this ID. We're either going to get nothing back, or we're going to get the actual inflated patient instance out of Realm. Those are just the Realm APIs. And the reason why I go through those is because FireKit's extensions to Realm are almost identical. You can see, we got the resources with, we want to get all the patients with the IDs of 1, 2, 3, or 4, 5, 6. And very similar to the objects, that's going to return a results list, which is lazy, which you can then apply your filter and your sorted functions to, and it's only going to inflate those as you start to iterate over them. Alternatively, like I said, we can fetch you can fetch a resource by its ID instead of the primary key. Chances are, unless you are setting your own primary key values to be something, calculus. If you want to make your own that's predictable, you can do that. But by default, we just use the UID string, so we can. So now there's the resource just to help us when we are working with the resource ID instead of a primary key. So that's retrieving. It's not hard. It's like 4 APIs chained together. Not rocket science. Before we start talking about updating, I want to go through a concept of managed and unmanaged objects in Realm. So an unmanaged object in Realm is simply an unsaved object. This is like a new thing that we just created. It's sitting in memory, but it's never been persisted to disk. So if we take a look at the patient example that we started out when we were creating, we create a patient, we create a human name, family name, the given name. All of these are unmanaged objects at this point. What that means is we can go and we can manipulate them to our heart's content, do whatever we want with them outside of any type of write transaction or any type of boundary. We can do anything we want. But at the point, though, when we go to persist it, that's when that flips from an unmanaged into a managed object in Realm. And now we start feeling those constraints that I talked about earlier. Now we can't persist it, we can't share it across threads, for example. So if we were to turn around on line 16 and try and set the birth date of this patient, this is going to crash your app. This is where we enter the world of pain, because that patient is now persisted, Realm knows about it, and Realm expects to actually update the data on disk when we mutate that data. So in order to get that to pass, we have to write it, or we have to wrap it in the write transaction. We can either use a write block, or there's also the begin write and the commit write methods, and anything you do between those two calls to that object is going to be within a transaction. The reason why this happens, I alluded to it, is once an object becomes managed in Realm, there are property observers on the properties that map back to the columns in Realm. So it will go under the hood and try and and persist that data as you mutate it, hence the need for a write transaction. So with that in mind, how do we edit this stuff? I mean, there's 4 ways. You can edit individual properties, which we've seen. You can set a birth date. You can set a gender. You can go through one at a time. That's doable. There's also in FireKit an extension for upserting an entire property, which I'll talk about. All of these I'm going to talk about. We can use a copy populate technique, which is also in FireKit, or we can upsert an entire resource. So those last 3 are all things that FireKit provide you. One thing, and this is the last time I say it, they all have to be done within write transactions. Write transactions. It's like the bomber developer, but for persistent nerds. So we've already seen this. We can create a patient, or we can retrieve a patient. We can open the write transaction. We can set the birth date. We can set the gender. We're modifying individual properties. There's no rocket science there. Alternatively, we can manipulate multiple objects within a write transaction. If any one of them fails, the whole thing fails. It's pretty standard stuff. But it doesn't necessarily work. Like if you think about if we wanted to manipulate a marital status on a patient. A marital status is a complex object. You've got a portable concept. That's got a bunch of properties. It's got a list of codings. Those have a bunch of properties. So if we're modifying individual properties, that can start to become tedious. Checking to see what exists, what doesn't exist, what needs to be appended, what needs to be created. It's not hard, but I don't think anybody here enjoys doing that kind of work. Like it's tedious and it's boring. It's boilerplate a lot of the time. So one of the things that FireKit provides is an upsert function, and it will upsert for I think most of the complex property types that it finds on a class. So for example, that's coming. So what upsert does is we can actually create a template of what we want that value to look like. So we can pre-create a codable concept, and we can add all the properties and fields to it that we want. And then we can assign that with the upsert function back to the patient that we actually want this codable concept to apply to. So in our example, if we go down the marital status bit, we can create the codable concept. We can create the coding. We can say, this is what I want the marital status to look like. And now on these two patients, I'm going to upsert the marital status to each one of them. What Realm is going to do is going to say, okay, well, spouse A, does spouse A have this color? Do they have a marital status? Is it 1 or none on a patient? Yes, okay, then I'm going to update that marital status to look exactly like the template that you've given me. If it doesn't, I'm going to create a new one. And what FireKit also does is it ensures that spouse A and spouse B don't point to the same status. So FireKit will also be responsible for making sure that spouse A gets their own and spouse B gets their own marital status. So everything is confined within that resource boundary, so to speak. So that's one thing that we can do. Another thing we can do, which is like the copy populate, kind of takes that idea and makes it a bit bigger to the whole resource. Because everything in FireKit, conforms to NS copy, we can do a deep copy. So I can take a patient from the realm, call copy on it, and in a single line of code, have a complete structure and value identical patient that is unmanaged, and that's the key. So the one that's returned is not managed by Realm. And because it's not managed by Realm, we can do whatever we want to it outside of a write transaction. You should know also it doesn't just get the primary key. So if you want to copy it and turn around and add a new one, you can do that in 2 lines of code. So once we have this copy, which is basically a template, and we've modified it a whole bunch, and we've got it to look how we want it to look like, how do we get that back into the original patient? Or into the original resource, pardon me. So Realm provides a populate from on, I think, every single thing that it defines. Everything in FireKit has a populate. And what that's going to do is it's going to migrate the values from our template and the structure of the template and overwrite whatever the target is. So this is very, very similar to upsert, but instead of doing it to a single property, we're doing it to that entire entity. So there's no intelligent merging. So there's nothing keeping track of when you made that copy and when you're applying the template via populate. It's not going to say, hey, you made this at, made the copy at 3:30. Now you're trying to apply it to something at 3:33, but we've had changes in between. It's not going to give you any warnings. It's optimistic. It's like, all right, this is what you want. This is what you're going to get. There's too bad, so sad if that's not what you wanted. So again, what does this look like? We create a patient. We can persist that patient. Now, if we wanted to make a whole bunch of modifications to it, think of it like maybe on a form where you're editing a patient on like a view controller and you want to have a cancel done, type of thing, where you can roll back those changes and not apply them. This could be a scenario. So we create a copy, which basically at this point, again, is your unmanaged patient, total copy of whatever you're copying. And you can start manipulating it to your heart's content outside of a write transaction. When you want to bring that back into the original patient, that patient has a populate from on it, and it's going to expect something of the same type, and you pass that copy back into populate. So basically your template. Modify the template and then reapply it back to the original. Now there's the bonus Jonas. I use these a lot. This one, I like this one. This one's really useful. So if we're talking to a server and we're getting a patient back, for example, or a few patients, how do we know if those patients are local or not? We can, write a bunch of boilerplate to create your object or your query. We can filter it and we can do all that stuff. And then if it exists, then we can update it. If it doesn't exist, we can insert it. We can do all that, but it's tedious. I don't like that. I get annoyed. So we can upsert it. So there is a extension to the Realm class itself via FireKit that allows us to it wraps all of what I just talked about, that boilerplate up for us, and it works on any resource. And it's based on the resource ID. So if you think back to the resource API that we had for fetching resources out of Realm, it's using that under the hood. It's also using the populate from under the hood. So everything that we've seen so far has just been wrapped up for us through this one API. So if we were to grab some remote patient from the server, don't know what it is, don't know what the ID is, don't care, I just want to get it into my local realm, but I don't want to make duplicates. I can just call realm.upsert and give it that patient. It's going to go and do all the heavy lifting underneath. It also handles multiple patients. So if we get a whole bunch of patients back, maybe we did a query on the server and we got like a whole bunch of bundle entries, each one's got a patient in it. We can grab those patients and upsert them all at the same time. And again, because this is in a write transaction, if any one of those fails, they will all fail. You'll get an error. In fact, right here, you're going to definitely get an error. You're going to get a full-on crash because we're doing the try bang. So that, typically, in my experience, when I'm working with our server at work, the upsert is the one that we're doing a lot when it comes down to like syncing data from the server back down to the client. So I don't have to worry about doing that. So the last one, the D for CRUD, is how do we delete a resource? How do we delete something out of Realm? They got an API, it's called delete, and it sucks. It's not a very good API. And the reason why is, again, if we think about the object structure of these resources, you have a patient. A patient can have many human names. A human name can have many realm strings, and many family names, many given names. You start to create this pretty complex tree. And when you use Realm's delete method, their API, all it's going to do is delete that single thing. So it doesn't cascade. So I'm going to delete this patient. That human name is still there. And all of the given names are still there. And all of the family names are still there. But now they're not associated. They're just orphaned. They're just flying around in space. You got a bunch of dirty, crappy data now in your local realm, and nobody wants that. So FireKit also has another extension on it called Cascade Delete. So if we have this patient with the human name, we can just blow everything away with that resource. It's going to cascade delete through all of it, and it's going to make sure there's no orphans. What it won't do, though, thankfully, is if you have a, say, like a reference, like a managing organization on that patient. It's not going to resolve that reference and go into that organization and now blow away everything there. That would suck. So it only stays within what I call like the hard relationships of that patient. It stays within that patient, it stays within that resource. It doesn't extend to loosely associated resources. So pretty predictable what this looks like. We can create our patient, we can persist it, and then if we ever want to blow it out of the water, we just call cascade delete on it, and it's going to go through and manage all that stuff for us. So that's our basic CRUD with FireKit. JSON serialization. So we got this data, that's great, but we want to share it with some server, we want to put it in a format that's computable. How do we do that? So in FireKit, every class that's defined in there, every patient, every codable concept, every organization, observation, everything in there, all conforms to Swift4's codable protocols, so encodable and decodable. What this allows us to do then is just serialize it. All we need to do is create a new JSON encoder and pass an instance of that resource to that encoder, and we're going to get some JSON back. If you are really having a hankering to serialize into property lists for some reason, this will also work because the FireKit classes themselves, they don't care what kind of encoder you're using, they're just conforming to the encodable protocol. So if we want to get data, or if we want to take the JSON and get it back into an instance, very similar, we just use a JSON decoder. And we tell the decoder what kind of type we're expecting out of this data, and give it the data, and what we get back is hopefully that type of resource, that actual and threaded instance. That's all there is to serialization. It's one-liners. So how do we integrate with the FHIR Server? This is important. This is kind of like something you do when you have a mobile app. You tend to push and pull data from somewhere. And how do we do it, especially since I said FireKit doesn't have an API client? There's nothing built in there for it. I'm looking at it, I'm wrestling, I'm thinking about some stuff here. One of the things I've done in the last year, though, is I created another library called Restivus, which is a generic REST client for iOS. And it operates also across Swift 4's encodable and decodable protocols. And because everything in FireKit operates over encodable and decodable protocols, I can marry these two together quite seamlessly without any actual hard dependencies. So I'm going to show you quickly what rest of this looks like, just to kind of wrap up this talk, mostly because my exercise has it. You can create some rest of this requests to exchange with the FHIR test server in my exercise, and you're going to see just like how easy this actually is. So if we wanted to just step away from FHIR, if we wanted to create a request that just grabs the Google homepage, first thing we want to do is model our request. We're not going to pass up any data. We're not filtering on anything. We're just going to grab the Google homepage. So Google home request, that looks about done. That's about all it is. The next thing we want to do is we want to tell the rest of this, is this a get? Is this a post? Is this a put? What kind of a request is this? The rest of this has, currently, 80-20 rule kind of thing. It has protocols for 5 of the major methods that are most commonly used. So we conform our Google home request to be a gettable. And what that means is we have to tell the rest of us a couple of things. What is our expected response type? Like the actual type of response, if we were to deserialize it, what would it be? And what is the format of that response? Is it XML? Is it JSON? Do we care? And the last thing there, of course, is where are we sending this request to? So on line 5, we're just saying, give me the raw response. I don't care what it is, just give me a bunch of data. Number 6, we say, well, this is not a JSON. This is just a raw request. We're expecting raw data to come back. And we're going to send it to Google Home. So what rest of this does under the hood is it actually creates a submit function for you using protocol extensions. It creates an HTTP URL request for you. It does everything that you would expect to do with a normal request in iOS. And it also returns a URL session data task so you can cancel that request if you need it. So when we submit it, we also provide a block that's going to be called back when it's completed. And that block is going to receive a generic result. It's just a generic email. And it's either going to be a success or it's going to be failure. And inside each one of those is additional information about that response. So in our case, this will be clear in about 30 seconds. That raw data that we have on line 14 is actually an inflated instance of our response type on line 5. In our case, because this is just a lame Google homepage request, we don't care, that's actually going to be an instance of an NS data object, or just data in Swift. If it fails, then we get like a rest of this HTTP error, which we can use to dig into why it failed. Did the deserialization fail? Did the server raise a 500? Like what actually went on? So there's a bunch of stuff baked in there. So if we go back to FHIR and say we want to download a patient, we want to use rest of this to make a request to a server to get a patient, how do we do that? So we can create a request. We'll get patient request. And it's going to take an ID. We are getting a request, so we want to conform to a gettable protocol. And you can see the difference here on line 10. Instead of raw, we're saying, I'm expecting the response type to be patient. And that's a FireKit patient. And then we have a couple of other alternative properties. If you don't want to use a URL, you can use a base URL and a path. The reason why I put that there is if you think about protocol extensions, you can create sensible defaults in your own application for all of this stuff. So we're going to go to the UHN, University Health Networks, where James and I work. We're going to go to, we're going to use that test server. We're going to go to the patient. We're going to string interpolate the patient ID. And our request is done. We can turn around, we can create an instance of it now and submit it. And what we're going to get back, if it's successful, is not patient JSON. We're going to get an actual inflated instance, like a FireKit patient instance of whatever that JSON was when it came down. So if I wanted to, on 22, I can just take that patient and immediately upsert it. I can create a Realm transaction and upsert that patient locally. If it fails, again, you get your error, you can investigate, react accordingly. So the last example here, if I want to post a patient, if I want to send something to the FHIR test server, what what do? I create an add patient request. It's expecting a patient. So again, we're just working with FireKit patients, and because they're serializable and deserializable, they work well with rest of us. I'm expecting the response type to be an operation outcome. That's defined in FireKit. It can be deserializable. I give it the URL again, and we're almost done. The thing is, we need to post something. So we gotta populate that HTTP body that we send it up. So how do we do that? The rest of this will check to see if the request that's being sent conforms to encodable, which is a Swift 4 protocol. And if it does, it's going to serialize that and stuff it into the body. Now, typically, that's fine if you're working with other things like maybe a login endpoint or something else in your application. If your request is modeled one-to-one with the data that you want to send up in the body, you're fine. But for us right now, that's not necessarily the case. If we were to just send this right now without the function on line 7, the encode function, by default, the rest of this is going to serialize a map that's got a patient key and the actual patient JSON as the value. We don't want that. We want just the patient JSON. So all we're doing in the encode function, which is what needs to be implemented to conform to encodable, all we're doing is saying, okay, I'm going to give you a single value, line 8, and that single value is going to be the encoded patient, which in our case is going to default to JSON. That's it. So the rest of this, when you submit that, it's going to serialize that patient, stuff it into the body, send it up. It's going to get a response from the server, and just like everything else, we're going to get an outcome, or we're going to get an instance of whatever we defined above, which was the operation outcome on line 14. We're going to get an instance of that operation outcome, and then we can start doing whatever we want with it. If it fails, well, we got the error. So even though FireKit doesn't have an API client, we can use rest of this. That's what we've actually been using for all of our data exchange with our FHIR servers, and it seems to be working quite nicely. It allows me to just focus on the structure of the request and the response, and not all the gobbledygook crap you got into the video. There's a lot more to the rest of this. There's I actually have full documentation of it online. It's actually readable, I think. You guys can tell me otherwise, please. So it's all there, we're good. So, real quick, sorry, that was 35 minutes already. In summary, you got FireKit. It gives you a Realm-ready schema of FHIR DSTU2. It's all in Swift 4. You can start using it, persist it immediately. You don't have to translate or juggle or do anything crazy. It also provides some helper functions for helping us update data in our realm, update resources, deleting those resources. It helps us with serialization, and it just provides some convenience things like NS copy. FireKit, or pardon me, rest of this, it's just a really simple REST client API. It just allows us to quickly create these requests, generate responses, and it mostly stays out of your way. And that's that. Here's a whole bunch of links. FireKit, open source, rest of this open source, both Apache 2 license. If you're not familiar with Swift 4 codables, there's 3 links here. One of them is the actual Apple developer documentation, which is kind of useful. The other 2 are written by the community, and they're fantastic. And if you want to find me on Twitter, Hemmingward, and GitHub, Ron Baldwin. I think these slides are going to be all made public as well, so if you don't get it down in time, it's all good. So 37 minutes, I got 2 minutes and 45 seconds to say I don't know to any questions that you might have. Anybody got anything? Oh.
So have you used that UHN to build actual apps?
Yes.
And can you give an example?
So the app that I started working on this last year, where all this comes out of, is an app called Breathe Again, which is a self-management questionnaire-based application for patients with chronic obstructive pulmonary disorder. So the idea is every day they can check in, the server keeps track of their exacerbation state, and it's going to fire down a questionnaire.
So is that a patient-facing app?
It's a patient-facing app, correct.
So if patients of UHN have Android, what do you do?
So there's a whole other team that's handling
okay.
the Android side of that, and they actually, I think they do have their own library for FHIR stuff.
Okay.
I'm not familiar with how it works exactly, but we are definitely using FireKit so far on 2 projects, and we're going to be starting up another one here, I think by the new year, which will also be using FireKit. So there is stuff I can show anybody that's interested. I have our Breathe Again app here also, and I can show you what that looks like. It's a chatbot type of app where we convert my questionnaires and responses into a chat application.
What are your timelines for moving to STU3?
Yeah, I got that question in July, and I said, give me a couple of weeks to investigate, and then I ended up doing a whole bunch of this stuff. It's like right at the top of my priority list of things to do is to start getting this into some more modern versions of FHIR. So timeline, I don't know. ASAP, it's going to be the next thing that I do as I dedicate more time to this stuff. So it is under development though, and it is like we're active on it, so it's there. We won't abandon you. Anybody else? I got 30 seconds.
This RESTful, the RESTful API,
Yes.
that is on top on the FireKit, or can you
No,
also
it is
use-
completely separate.
Okay.
It's totally separate. It's not on top of FireKit. It's its own thing. You use it outside of FireKit.
So it can be used with also different objects, for example.
Totally. Yeah. The main thing is it operates over Swift 4 codables. So
Okay.
so long as you're using whatever your structured classes are conforming to Swift 4 codables, you'll have seamless integration with the rest of this.
Okay.
All right, that's it. I'm out of time. Thanks.